Okay, good afternoon, gentlemen. I hope you had a good meal. I figure some of our friends are yet to come, but we will have to start on time. So let's move forward. I now call upon Mr. M. Arumugam, Council Member of the IAF Chennai Chapter, to introduce our seventh speaker of the day, Mr. Anirudha Kandekar, Senior Manager, Sales and Technical, Forace Speciality Chem Private Limited, Haridwar.
Good afternoon. Mr. Anirudha Kandekar is a Senior Manager, Sales and Technical in Forace Speciality Chemicals. He is holding Masters in Manufacturing and Industrial Engineering from IIT Kharagpur, having 18 years of experience in casting design and development for foundries and OEMs. Having hands-on shop floor knowledge about various molding and line systems, innovative method design, result analysis with simulations, pattern and core layout design, defect and root cause analysis with NDTT, successfully designed and implemented more than 900 ferrous and non-ferrous casting across 400 foundries. Mr. Anirudha, thank you.
Yes, very good afternoon, everyone. So, being a method person, there is always demand from various foundries to improve the yield. So, with this slide, we just see ki if you consider only 5% of yield improvement in the metal, as well as 5% saving in the product cost, then what will be the saving we are going to get for the foundries? So with 5% of saving, we can save the metal as well as save the product cost also. There are two aspects. Just consider one foundry which is making a 350 tons of steel wall castings with average yield of 53%. So if you save 5% of metal, then annually they will be going to get around 10 lakhs of rupees of saving. And if they save a 5% of product cost, then they are going to get around 3 lakhs of rupees per annum. So overall put together, it will be around 13 lakhs. So, but to save this much of money, or you can to get this much saving, there are various customized solutions available to various foundries as well as for the OEMs also. So for OEMs, it can be helpful in new casting design, in simplify the casting profiles, reduce the development time. Also, we can reduce the cost by optimizing the casting wall thicknesses and the hotspots. For foundry, it will be a new casting development, it will be a faster. Then faster development, I already said. Then method design and layout designing will be easier. Product application will be easier. Then rejection control we can do. Yield improvement we can do. Also cost saving projects we can do with the customized solutions. So to do this, there are various challenges. In casting areas, it will be because of thin wall sections, the more isolated hotspots are coming, which are very difficult to fill. Then because of high pressure molding lines, it is very difficult to use the feeding system products in them which will be capable or which can be used with the speed of the molding. Then obvious, because of this, all these things, application of the products is very critical. So we are there to help you in the method in design and application of the feeding system products. We can design the methods which can develop the casting faster. Then feeding system design we are going to do. Running system also we can support with help of filter and other stuffs. Then pattern design also we are going to help, like in layouting, then all core boxes designing. Then we can help you or help various foundries in as a problem solving tools also. We can take up projects like yield improvement projects, shrinkage reduction, or defect reduction projects. And also we can organize a training, specific training for the various topics which are there in the foundry. So here are some typical cases I have included to start with. Here, this is a railway casting in which the customer or railways demands is to get a sound casting or a level 1, radiography level 1 casting. So previously what they were doing, on the flanges they were using a regular round sleeves and they are using a metal pad below it, so that the fettling time and knockout time has been increased. So what we have done, we have reframed all the methoding system. We have, on the flange, we have used slotted ND to reduce the fettling. And to increase the solidification time, we have applied half-cut open sleeves at the base of the risers, so that the solidification time will be increased. This is another application of the open sleeve as well as a slotted sleeves. So here also, this is also a railway control arm casting. The customer wants, actually customer tried so many methods, but they were not able to get the level 1 in the radiography. We have supported them, we have proven them with the single cavity layout, and now the customer is doing the second double cavity layout. This is another third part of that casting, that is top control arm. So here also the level requirement is the same. So here we have given them 2 proposals with regular ND sleeves also and with slotted ND sleeves also. So this is one typical example or a case study which I want to show. Previously, the customer means the main focus is to reduce the knockoff area. So previously the customer were using a regular sand riser and regular neck connection. So what we have suggested, we have changed that neck and we have applied a neck down sleeve instead of the regular sand riser neck. So the fettling and knockoff area has been reduced from 6,000 mm square to only 1,200 mm square. That has been reduced by almost 25%. So this is also a typical case study of the steel casting. These are the steel casting called as idler castings. Previously, customers were applying the sleeves on the top of the casting, and to feed the bottom areas, they have increased the wall thickness, and they have inside the casting there are thin wall sections or thin wall were present. So instead of that, they have increased the wall thickness. So you can see the casting weight was 130 kgs instead of regular casting weight of 90 kgs. So that much extra casting weight they were giving to the customer. So we have changed the method, and that totally we have eliminated all the extra padding what they have given or extra wall thickness, and that has been reduced to the optimal level of 90 kgs. So this is a typical example of the application of the slotted ND sleeves. So previously customers were using a telluride paste which was costing them around 160 rupees per casting. So we have totally eliminated that when we have introduced 6 number of slotted ND sleeves, and the casting is sound now. So this is typical jaw plate casting where the customer wants a sound casting because of they are feeding from the one side, they could not able to get a sound casting. So what we have done the simulation study of that casting, and according to the solidification behavior, we have changed the location and we have suggested them a regular open sleeves. This is a typical example of application of the angle neck down sleeves on an angle surface casting. So, and one more demand, previously you can see the original method, it is having a risers from the outside, and the customer also want to reduce the mold box size to improve the sand to metal ratio. So what we have done, we have given them a solution with the angle neck down sleeves, which has been given from the inside of the casting. So this is the brake drum casting typically. So this is a new development casting. Customer has not done any trials for that. So two layouts we have suggested. One layout is with only vents on the top. If after the trial, if the customer gets any shrinkage in the hot junction of the top areas, then we can go for the slotted ND sleeves. So this is a typical application of the neck down sleeves. So previously the customer was using 4 number of open sleeves on the casting and the pad below the sleeves. So what we have done, we have closed the center bore and we have given only 1 ND sleeves. Here in this casting, the customer were using number of chills, I think it's 18 number of chills they were using along with the 4 number of open risers and the metal pad below the open sleeve. So typically like from the first case study what we have done, we have used them or we have proposed them a neck down sleeves as a connection in between the casting and the sleeves, which has been to increase the solidification time. And we have eliminated all chills, and with only neck down sleeves and open sleeve at the center, the casting is okay. So in this case study also, customer want to eliminate or reduce the number of sleeves. In original method, there were around 6 number of sleeves, and with our proposed method, there are only 3 number of sleeves. This is one typical example of the shell molding. So where the filter and the direct pour sleeve has been used by the customer, which was costing around 35 rupees. What we have done, we have changed the same modulus and same volume sleeve to the open sleeve, and we have the cost has been saved by almost 50%. The results are same. So related to feeding systems, we need to feed the hotspot to eliminate the shrinkage. That is the main requirement of the feeding system. So in feeding system, there are, like you all know, there are insulating and insulating plus exothermic sleeves. There are various types like open sleeves, blind sleeves, neck down sleeves, direct pour sleeves, boards, leads. In powder products, we are having APC. And we can offer you with the application of this sleeves and powder products, we can give you methoding proposals. So we have 3 different grades according to the MEF or according to aluminum content. We have 800, 400 and 100. In insulating we have 1000, and direct pour sleeves also we are having. So MEF and aluminum content you can see. And we can customize that also, which according to your foundry practice or according to your foundry needs, we can customize the aluminum content also. So 2.5 years back, we have started the manufacturing of the sleeves. So we have, in open sleeves, we have up to 18 inch, we are having open sleeves. Up to 8 inch, we are having blind sleeves. Direct pour sleeves, all range we are having. In neck down sleeves, we can offer you customization in the neck openings as well as a separate cone also we can provide you, and separate cylindrical sleeves also we can provide you. And neck down slotted sleeves are also available. And these are the angle neck down sleeves. Cover leads to make open sleeve as a blind sleeve. We are having cover leads also for all types of all sizes of the sleeves. Call boards, or you can say boards, which can be used to feed the thick section from the thin areas. So generally they were using a metal pad. Instead of metal pad, we can use boards. Various types of breaker core to reduce the fettling time and grinding areas. Anti-piping compounds are also available to increase the solidification time of the sleeves or metal. So regarding the application, how we have to apply the sleeves. So there are three methods. First one is insert, second one is ram up, and third one is a close over, like you are putting a core and the mold will be coming from the top. So these are the typical insert pegs which has been used in the foundries. So there are two types, you can say, a cylindrical regular sleeve, and one on the left side it is a slotted sleeve, insert pegs. These are the typical ram up pegs for the blind sleeves as well as for the open sleeves. This is typical, you can say, a ram up peg or insert peg for the neck down sleeves. For generally in steel casting or no bake casting, metal pads are, or you can locating pads are used. This is the application for the vertical lines, or you can say a Sinto Hunter type molding lines. So direct pour sleeves or open sleeve, we can insert it after the mold has been prepared from the top. And on the left side, there are two pegs which has been used as a parting line. So it will be insert peg. So in Forace, we are periodically doing the performance evaluation of our sleeves. So typically, the feed safety margin we are claiming is from 25% to 30%. So for all sizes, periodically, or you can say a quarterly, or with the new batch, we are doing the cube test. So these are the cube test results for various sleeves. Also, we are doing the burn test to get the burning rate. So this is the typical burn test which has been done at the customer end, because this is not a laboratory setup. This is a mold, and on the mold we have kept the sleeves. So in exothermic sleeve it should burn, and insulating sleeve it will be, you can say it should not burn, it just insulate. And with our proposals, these are the some typical cases or actual photographs of the casting where we have started using our sleeves. So all over India, or you can say all over in South Africa and UAE also, we are supporting various foundries for the sleeve application and methoding supports. So thank you.
Thank you, sir. I would like to invite Mr. P. Sendil Kumar, Chairman of the IAF Chennai chapter, to felicitate Mr. Anirudha Kandekar with our traditional Angavastram. Along with our memento. Thank you, gentlemen.